Okay, here's a circle geometry problem, and it's always good to read this thing really careful. We got two circles here are given in the diagram below. They intersect at points S and T. That's where they cross each other. And here's an important one. RVT is the diameter. This is the diameter of the larger circle. V is a point on the circumference of the small circle. But TP is tangent, real important, to the smaller circle at T. R is 50 degrees. There's that R is 50 degrees. And T2 is 40 degrees. Well, that's what we need to know. Okay. Now we got to find these three things. Gee, they're not really so very hard. They ask, what is angle TSR? Well, it opens up to a diameter, and you just should know it. It's one of the basic first things. An angle that opens up to a diameter is 90 degrees. So this whole thing, TSR here, is 90 degrees. Angles on a semicircle, 2 marks, pretty easy. Let's find angle W. Angle W right there. Well, if we could get this angle, T1, we'd be in good shape. And it looks to me like if that's 90 degrees and that's 50 degrees, T1's got to be 40 degrees because the angles sum in triangle STR. Well, if we know that's 40, look, in the small circle here, W and T1 are angles on the same segment, SV, of the small circle. So W must be 40 degrees, angles in the same segment. Oh, a nice, easy 4 marks. Well, if you see it, I guess it's all easy if you know what you're doing. And S1 is 40 degrees. Let's see here. Why is S1 40 degrees? Well, because there's the angle between the tangent and the chord, and inside this small circle, that's the angle in the ultimate segment at the top of the triangle on the other side. So there's your 40 degrees. S1's 40 degrees. That is the tan chord theorem. Well, there you go. There's question 8.2. All done.